This is my Module 7 video on matrices. I decided to choose the problem where you had to find the multiplicative inverse of a matrix, and then I want to show that it actually does work. So we were given matrix B, which is a 2 by 2 matrix. So we have 2, -1, 3, -1. We want to find its multiplicative inverse. So when we were dealing with numbers, we had like 4 times what would let it stay the value of 4. So that would be 1, right? So what we want to try and do with the matrix is say, I have my matrix B. What matrix could I multiply it by to have it remain itself? So I plugged in some letters, A, B, C, and D, into this matrix, and we're going to try and solve them to figure out what its multiplicative inverse would be. What I did was I multiplied my matrices together. So to do that, with multiplying matrices, we take the first row, multiply it with the first column, so I do 2 times A, and add that with -1 times C, which we see here in yellow. Then I do 2 times B plus -1 times D, which we see in pink. Then for this bottom row, I do 3 times A and add that with -1 times C, which we see in blue, and 3 times B plus -1 times D, which we see in green. And my goal is to have those equal my original matrix B. So what we can do now is come up with some systems of equations. So I see that this column here deals with A and C. This column here deals with B and D. So what I did was I took those two equations and their corresponding values in our B matrix and wrote two equations. And I'm going to solve these systems for A and C and B and D. So what I did for the A and C matrix, I solved the top equation for this C value, so I'm using the method substitution. So when I solve this for C, I get 2A minus 2. And then with my B and D system, I solved the top equation for D here, and I got D equals the value of 2B plus 1. So when we're using substitution to solve, what we want to do is I want to take this value, oops, that is way too big. Bring that down a little bit. I want to take this value of C and substitute it into that other equation for C. And that way I have a one variable equation which I can solve. So we're going to do the same thing over here. I have this value of D. I'm going to substitute it in for D in this bottom equation because I solved the top equation for D. So substitute it into the bottom equation. We get a one variable equation and I can solve for the value of B. I'm going to do this together. What I did when I substituted this value of C in, 3A minus 2A gives me 1A. And when I subtracted negative, it's the same thing as adding 2. So A plus 2 equals 3. Well, that means 1 plus 2 has to equal 3. So the value of A should be 1. When I solve for B here, 3B minus 2B, well, I'm left with 1B. And when I subtract a positive 1, it's really just the same thing as subtracting 1, right? B has to be 0. 0 minus 1 should be -1. So I'm halfway done. I still need those values for C and the values for B as well. So I decided to plug this value of A into this top equation and solve for C, right? Times 1, well, that's our multiplicative identity, right? We'll get the value of 2. Well, 2 minus 0 has to be 2, so C has the value of 0. And then I decided to plug this value of B into the top equation of my system. 2 times 0, well, anything times 0 is 0. So 0 minus D equals -1. So 0 minus 1 needs to be -1. So D has the value of 1. So what does this tell me? So now that I've solved my value for my values A, B, C, and D, remembering that my letters were A, B, C, and D, right? Our inverse matrix should be 1, 0, 0, 1. So now I just want to double check this and make sure that it's actually true. So what I'm going to do is we're going to go back to this problem here, and I'm going to substitute those values in, and we'll see if I actually end up with the original B matrix when I multiply them. So we check. So we have our original B matrix. I'm multiplying it by this inverse matrix, and we should end up with the same values for that B matrix. So once again, when we're multiplying matrices, right, this row with this column, add them up. This row with this column, add them up. The second row with the first column, add them up. The second row with the second column, multiply and add them up. And hopefully, I should be getting this B matrix, but I don't know right now. So I'm going to simplify these. Well, 2 times 1 is 2. -1 times 0 is 0. Well, 2 plus 0 is 2. 2 times 0 is 0, minus 1. So 0 minus 1 is -1. 3 times 1 was 3, plus 0. 3 plus 0 is 3. And then 3 times 0 is 0, minus 1. Well, 0 minus 1 is -1. And I do end up with my original B matrix. So I know that this matrix here, 1, 0, 0, 1, is our multiplicative inverse. And it is our inverse matrix.